We use speech and language in a variety of different ways, from laughing and singing to calling our friends on the phone or acting in a play. It comes naturally to most of us and is an important part of our day-to-day life. But do we ever really stop to think about how amazing and intricate the production of speech really is? It's important to understand how we produce speech so that we can learn the best ways to avoid vocal misuse and keep our voices healthy for all the activities we enjoy. Voice production relies on three systems working together: respiration, phonation, and resonance. Without any of these functioning properly, typical voicing cannot occur. So let's dive a little deeper into each one. Let's start with your lungs, which are the power source for your speech. Try holding your breath and talking. Place your hand right in front of your mouth while you talk and make sure no air comes out. You can move your mouth as much as you want, but you can't say anything without air. This is why respiration is considered the driving force for speech production. Respiration includes breathing in and out of your nose and mouth. Various muscles work together when you inhale and exhale, including your diaphragm, the main muscle of inspiration, or breathing in. A proper amount of airflow from the lungs through the larynx will blow apart the vocal folds, also known as the vocal cords, creating phonation, which we'll discuss next. You can think of voice production as the sound produced by a wind instrument, such as a saxophone. Think of your vocal folds as the reed. Imagine the musician providing the air as the lungs, and he must blow the correct amount of air onto the reed to create a vibration to send a sound through the air column. Respiration is analogous to the person blowing the air into the saxophone. Let's move on to phonation. The way we get the sound in your voice is through using your voice box or your larynx. It's here that the air from your lungs causes your vocal folds to vibrate. The air that is being pushed through our vocal folds during respiration is being interrupted by the opening and closing of our vocal folds. That is what causes sound, or phonation. The vocal folds are capable of shortening, which decreases pitch, and lengthening, which increases pitch. It's important for the vocal folds to make a complete closure in the middle of a vibration, because if portions remain open, the voice quality may sound breathy or weak due to too much air escaping. When thinking back to our saxophone example, phonation is analogous to the vibration of the reed. Without the reed, there would be nothing vibrating to create a sound wave. In our saxophone example, resonance is analogous to the sound wave bouncing around in the air cavity of the saxophone. So think of the inside of the saxophone as being the same as your vocal tract. The acoustic energy will move through your pharynx into your oral and nasal cavities. Each will have a distinct effect on the quality and strength of the acoustic signal. If we were not able to shape the sound with our vocal tract, then the sound of the vocal fold vibrations would come out as a flat buzz, completely unrecognizable as a human voice. Many singers, actors, and other professional voice users dedicate much time and practice into manipulating the shape and size of the vocal tract in order to change how their voice sounds. These physical attributes of their voice that they wish to manipulate are called pitch, loudness, nasality, and quality. Overall, voice production requires a perfect combination of respiration, phonation, and resonance. When considering the saxophone example, if any part of the saxophone is missing or broken, or if airflow is insufficient to correctly vibrate the reed, the sound will be distorted. The same thing goes for your voice. The vocal folds are an integral structure in our ability to produce sound. They do this by vibrating back and forth. Each of the 5 layers that make up the vocal folds have different compositions and mechanical properties that provide flexibility and stability. The epithelium is the outermost layer and is also the thinnest. Any damage to this layer will impair the ability to produce sound. It is important that this layer has some slippery mucus lubrication so that it vibrates at its best. The epithelial cells are the first to be exposed to environmental influences like humidity, dehydration, pollution, and reflux secretions. The next 3 layers of the vocal fold form what is called the lamina propria. These layers are made from fibrous proteins called elastin and collagen, which provide both elasticity and stability. The lamina propria is divided into 3 distinct layers: the superficial layer, also known as Reinke's space, the intermediate layer, and the deep layer. Together, the intermediate and deep layers of the lamina propria form what is called the vocal ligament. The last vocal fold layer is called the vocalis muscle. It is the main body of the vocal fold and provides tonicity, stability, and mass. It is far denser than the other vocal fold layers, but does still oscillate with vocal fold vibration. This layer of the vocal folds is the only one that can respond to neurologic control, meaning that it can contract and relax to modify vocal fold tone and tension. A way to visualize inside the throat and observe vocal fold functioning can be done through a rigid or flexible videoscope. A videoscope is an instrument that has a camera and a flashlight attached to it, which can be inserted through the nose or mouth. This allows the structure of the vocal folds to be examined more closely, as well as their vibratory patterns. A videoscope can also incorporate a strobe lighting technique to help visualize vocal fold movement during speech production. This can assist in observing problems that may be present, such as abnormal movements of the vocal folds, any bumps or swelling, or any changes in anatomy. Here is a short video stroboscopy clip performed on a female patient.
Go low to high.
Watch as her vocal fold and throat shape changes as she produces higher pitch and lower pitch sounds. There are many different factors that contribute to successful production of voice. The anatomy and physiology behind speech production is quite intricate and allows us to talk, sing, laugh, and participate in life activities. Understanding how our voices work makes us appreciate and want to care for all of the hard work our body undergoes to produce sound.